to the last lesson on electricity and current, and we're going to be talking about electromagnetism in this lesson. So first, we talked a little bit about magnets. Electromagnetism, it's exactly what it sounds like. It's relating current to magnets and how that relation is at all useful. Well, first we want to talk about where we believe magnetism comes from. So, in other words, how do magnets work? Well, typically you think of a magnet looking something like this with the north end and the south end. What this really is using electrons' natural spin to actually help us to create a magnetic field. When we have a magnet, what that means is the electron spin is all lined up in the same direction. When you get a lot of electrons moving in the same direction, you're going to create a magnetic field. And so without going too much into it, why I recommend this video, magnets, and how do they work? You see it relates the electron spin with the north end and the natural south end to magnets. When you get something that works as a magnet, what that means is these electron spins have all lined up in the same direction, therefore working together to create a magnet with a north end and a south end within a material. This is a link. I'd recommend you watch it. It's 5 minutes long. But for now, let's continue with electromagnetism. Electromagnetism shows that electricity and magnets are parts of the same physical phenomenon. That's what we just talked about up here. What you note is that, hey, electrons lined up, moving in the same direction, aligned, that is actually the definition of electricity. We've got moving charges or electrons. And it's also the same thing for magnets. They're lined up in the same direction, they're moving, and we've got a magnet. What this means is they are super related, and we can use this relationship to our advantage. So, a magnetic field, we've talked about this last unit, is produced by a moving charge. So, in the example you see here, you've got a nice charged capacitor. The field would look something like this. If I move a charged particle close by and put it at a velocity, remember it needs to be moving and charged, we can now create a magnetic field with this situation. Same thing as if I created a similar charge, put it at the top. We have a magnetic field. Well, where in reality do we see this happening? All the time. The really basic examples that are most significant are in generators and motors, which are the exact opposite setup of a generator using very similar components. We're going to look more at these in class so you can see an example and see how they work using moving charges to create a magnetic field. Additionally, we're going to create speakers in class, mini speakers, but these are very similar to what a larger speaker looks like and use the same components. All of these things use moving charge, which we're going to refer to or think of as current. Current through a wire is charges moving. That is our moving charge. And that's going to produce a magnetic field that we can use to our advantage. So that is the first set of examples. But we can also reverse it. We can create a conductor, we can move a conductor through a magnetic field, and that will induce two things. First, a voltage, which we're going to call an EMF. And secondly, a current. So in other words, by taking a magnet and moving it through something that could conduct, we can actually create current. We can create something that's going to be conductive. And using materials like the voltmeter and ammeter, we can measure the amount of current and the amount of voltage in the circuit. So for example, this is the exact opposite of the one above. Here's your magnet, north end, south end. If we have a wire, something that's conductive, a copper wire next to it, we can actually, by moving this conductor through this magnetic field, we can create current through that wire. That's used in a generator. What we're doing is using mechanical energy, moving a wire within a magnetic field to produce current through that wire. That's how we're going to create a generator. So let's just take a look at a quick example. A small object is dropped through a loop of wire. We see that's conductive. and this is shown in this picture below, connected to a sensitive ammeter, meaning we can read current. A reading on the ammeter is most likely produced when the object falling through the loop is A. We need to say, hey, we need to produce some current in this loop. This is just conductive wire. It is not conducting anything yet. It is not connected to any kind of voltage source. But if we drop a certain object through this loop, we can induce a current. Well, we know that magnets moving through things that are conductive will induce a current. That's electromagnetism. So in order for us to get any type of current, we need to insert a bar magnet. And if we were to flip this question around and say, what if I had a magnet and a wire and I wanted to induce current? What I need to do, I wanted to create a magnetic field. What I need to do is move any kind of charged particle. So again, this exact opposite example, what we need is a charged particle in order to induce some current. Thank you for watching.